Guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 877 stone game. So this particular problem is super tricky and also at last you will be having a twist. So don't skip any part of this video, just watch all the video till the end. Okay, fine. So see here, Alice and Bob play a game with piles of stones. There are an even number of piles arranged in a row, and each pile has a positive integer number of stones, piles of I. This positive integers, so this term plays a major role in this problem. Okay, I will be telling that in last. Okay, now see here, the objective of the game is to end with the most stones. The total number of stones across all the piles are even, so there is no tie. Alice and Bob take turns, with Alice starting first. Each turn, a player takes the entire piles of stones either from the beginning or from the end of the row. This continues until there is no more pile left over. So which person has the more stones, okay, they will be winning. That's it. So if Alice wins, we want to return true. If Bob wins, we want to return false. That's it. For example, they have given the piles like this. Okay, then I can tell you, like first attempt is going to be Alice, right? So the first turn is going to be Alice. So let me assume Alice is taking this zeroth in this, because Alice can take either zeroth in this or the third in this, as they have given in the question itself. Either take the start or the end. Okay, now Bob will be taking either this 5 or this 3. So Bob is taking this 5. Let us assume. Now again Alice is taking this 4. Now Bob is taking this. So now who has a more number of stones? Alice has the more number of stones. Okay, so this is one of the possible ways of playing, right? But both the players are playing optimally. That's what stated in the question problem statement, right? So see here, we want to check in whether in any other possibilities or in any other combinations Bob wins. Okay, here Alice wins, right? Now let us check in different manner. Let us take, this is Alice. Alice took this this 5. Okay, now Bob, instead of taking this 5, let him take this 4. Okay, now again Alice will be taking this, again Bob will be taking this. Now also Alice is winning. Can you understand this? So if you put any number of combinations, Alice is going to be the winner. Okay, that's what they have given in the problem statement also. So that's the reason why they are returning true. Okay, so how we are going to do this? And what is the logic behind it? So in simple words, I can tell you the logic is going to be, we want to find all possible combinations. Okay, and if in your optimal combination, if Alice wins, then we want to return true. If Bob wins, we want to return false. Okay, and we are going to use the recursion and backtracking. If you don't know about the recursion and backtracking, don't worry, I'll be giving the playlist link in the description. Just go and watch the playlist completely so that you can understand how the recursion works in a DFS manner, what is recursion tree and what is recursion stack. So these three are major part for your DP. Okay, so please go and learn that, then come back to this video. Fine. Now see here, how I am going to frame the recursion. We are going to find all possible combinations, right? So how I am going to frame the recursion? So first of all, I want a function, and in that function we want to decide what are going to be the varying parameters. So what are going to be varying parameters? So see here, we have this array. So now I want the start and the end value of it, right? We want start and the end value of it. So let me take start and end value. Let me refer it like INJ. That's it, INJ. Can you understand this? Because they have, for Alice and Bob, they have two choices. Either they can take start or they can take us end. Okay, beginning or end. That's their wish, right? So that's the reason I am taking like INJ or start and end. That's your wish. Okay. Now let us draw the recursion tree. How the recursion works. Before that, I want you to understand, many people don't know about recursion. Okay, they don't know why we are using the recursion, but they know the recursion tree, how recursion works, everything, but they don't know why we are using the recursion. For those people, just listen this carefully. We are using the recursion because we have a big problem, a huge problem. We are going to divide that problem into a subproblem such a way that we are going to find the subproblem solution to combine all the subproblem solution to give the solution for the main problem. Now hope you understand what is meant by recursion, right? Now with that in your mind, now just focus on this. How I am going to split this main problem into subproblem. So anything like for Alice and Bob, they have two choices. They can either take at start or they can take at end. So let me assume first at start. Okay, both of them are taking at start. Okay, then what should I do here? I'll be taking files of I minus f of I plus 1 comma j. You may think, why I am putting a minus here? See here, I am just checking whether, like, I am Alice, I took something like I took the beginning file. Okay, then I want to subtract from the Bob value so that I can check whether he is greater than me or I am greater than him. If it is negative value, he is greater than me. If it is positive value, I am going to greater than him, right? That's the reason why I am doing a subtraction here. Okay, can you understand this? Similarly, if I am going for end, then what should I do? Files of j minus f of I comma j minus 1. Can you understand this? Fine. So this is going to be your division of the subproblems. Okay, now let us enter into the recursion tree. So how we are going to construct the recursion tree? So initially our function will be starting from 0 to 3 because we have a length of 4, right? 5, 3, 4, 5. Okay, now listen this carefully. This is going to be a crucial part. So see here, first of all, I can split as what? I can either take the 0th index. If I take the 0th index, it will be like 5 minus f of 1 comma 3, or I can take the third index. If I take the third index, then it will be something like 5 minus f of 0 comma 2. Yes, similarly next time here f of 1 comma 3. So here I can either take the first index. If I take the first index, then what is the first index? It is 3, right? So if I take 3 minus f of 2 comma 3, or I can take the third index, 5 minus f of what is the value? It will becomes 1 comma 2. Here also similarly, I can either take the 0th index. Or I can either take the second index. Can you understand this? So this is how we will be completing our recursion tree. Before that, I want you to understand. See here, Alice is going to be starting with first. So this is the Alice turn, and this is going to be Bob's turn, and here also Bob. So I want you to read like Alice took the 0th index, the start element. Alice took the start element, and Bob also took the start element. Then this is the recursion tree for that, the recursion branch for that. Okay, if Alice took the beginning and Bob took the ending, then this is going to be your branch after finishing this entire recursion tree. Can you understand this? Similarly, see here, this is going to be very important part. See here, listen this. So what it signifies? So what this signifies, this and this, it signifies for Alice, I took some value, right? I am going to subtract some value which has been took by Bob, and when I subtracting this, if the result, listen this is going to be a crucial part, is greater than 0, then I can tell you Alice win. If result is less than 0, then Bob win. Can you understand this? Why I am putting Alice win and Bob win? If result is greater than 0, what I mean is, what is my result at first of all? Result is equal to Alice number of stone minus Bob number of stone, because Alice is the one who took the stone at first, right? So here what I am doing, Alice minus Bob, next Alice minus Bob, like that. It will be going on. Can you understand this? So from here I can tell you, if the result is greater than 0, then Alice wins. If the result is less than 0, then Bob wins. And many of them will be asking, if result is equal to 0, then who wins? No, there is no tie. There is no tie. That's the reason why I am using only 2 conditions. Okay. So after finishing this, my recursion tree will be something looks like this. Okay. If I want to draw this, it takes much time. That's the reason I am just copy and pasted. So for taking this video, my laptop actually hanged for 2 times. So this is my 3rd time. That's the reason why I didn't draw this recursion tree. Okay, fine. So see here. So this is how your recursion tree something looks like. Now, what is going to be my base condition? My base condition is, my start point is also standing at the same point which is equal to the end. Which means what? Start is equal to end. So what is my base condition? I is equal to j is going to be my base condition. If it is so, then I want to return files of I or j whatsoever. You can return either of them. I and j will be same, right? So why I am returning this? See here, you took everything. Bob and Alice took everything, and at last there is only one stone, only one pile. Then they are forced to take that alone. Okay, they don't have choices like start or end. That's the reason I am doing this. Okay, so let me write this: 5, 3, 4, and 5. Now tell me what is in the third index. It is 5, right? So it is substituted 5. Can you understand this? Can you understand this, right? Now 4 minus 5 is equal to minus 1. So here it will be returning minus 1. Here it is 2, 2. 2, means what is at the second index? Second index is 4. So 5 minus 4 which is equal to 1. 5 minus 4 which is equal to 1. Now among them, which is maximum? So here many people will be thinking like, hey, why are you taking the maximum? Why we didn't took minimum? See here, we are taking the maximum because they are playing in an optimal way. And also we are just came out with the result is greater than 0. Result is greater than 0. What it signifies is Alice number of stone minus Bob number of stones. Okay, so I want to take the maximum among these two things. I want to take maximum among these two things. Same will be applied in everything. In everything. For Bob also it will be applied. Bob also playing in an optimal way. Alice also playing in an optimal way. So they will be taking the maximum only. Okay, so what is the maximum? It is 1. So substitute here as 1 instead of this entire function. Okay, so 1. 3 minus 1 which is equal to 2. Okay, now 2, 2 is substituted as 4. So it will be returning minus 1. So 1, 1 which is 3. So it will be returning 1. Now again, what is maximum? It is 1 is the maximum. So instead of this, I will be returning 1. So 5 minus 1 is equal to 4. 4 is written here. 4 or 2, 4. So instead of this, I will be replacing as 4. So here it will be 1. Here it will be 1. Similarly, come to here. F of 2, 2 is 4. Now 3 minus 4 which is equal to minus 1. And here it is 3 and it will be returning 1. And among them, maximum is 1. And then here it will be returning 4. Okay. Similarly, 1, 1 is 3 and 0, 0 is 5. Here it will be returning 2 and here it will be returning minus 2. And here it will be substituted as 2 maximum among them, and 4 minus 2 which is equal to 2. And then 4 or 2, 4. So 4. What is maximum among them? 4. So it will be returning 4. 4 is what? Greater than 0, which means Alice 1, which is true. Can you understand this? Right? So this is how the recursion works. Fine. So now hope you understand how I divided the problem into subproblem, and again how I am just combining the subproblems to create the solution for the main problem. Fine. So this is what the entire solution. Now tell me what is going to be the time complexity. So time complexity will be O of 2 power n. Okay, or it will be 2 power n square, goes up to 2 power n square. Yeah. Okay. Now what is space complexity? It will be O of n square. So this is your time and space complexity analysis for recursion code. Okay. And if I mentioned any wrong here, please comment in the comment section because I am unsure of this. Okay, fine. Now let us see the code for this, then we are just going to optimize it. Okay, fine. So see here, I given the Java code. If you want C++ or Python code, just see in the description. Okay. Now What is the base condition? If I and j are same, then I want to return the piles of I, or you can return the piles of j. That's your wish. Now, if there are two recursion calls, right? There are two recursion calls. Like, I can take the start or I can take the end. If I take the start, it will be like piles of I minus dp of I plus 1 comma j. Okay. If I take piles of j, okay, which means right side, or which means the last element, the ending element, then this is going to be a recursion call. And at last I want to return the maximum among them because they are playing in an optimal way. Okay. If you take the minimum among them, you want to change here as lesser than 0. It's just a recursion. Just go and rerun it so that you can understand what I told here. Okay. So that's it. So this is going to be an entire recursion code, and if I submit this, it will be not submitted successfully because see here, what is the length? It is 500. So if it is 500, it will be 2 power 500 the whole square, which is huge, which is greater than 10 power 9 the clock time. So it will be not submitted successfully. So let me take this and we can further optimize it. So the next step of optimization is memoization. So what is memoization? We are going to store the computer value in my memory so that in future if I want again, then I will be just taking from my memory and releasing it instead of going to for all its all same parts. Okay. For example, see here, follow the white color line. So this and this, these two functions are same functions, so they two are returning the same value. Here also it returns 4, here also it returns 4. Okay. And recursion works in a DFS, which means at first I will be computing this, then only I will be going for this, Okay. So if I store this 4 in my memory, instead of going for all these recursion calls, here it is 2, but in your real time it may be of 10,000. Okay. For going for all this recursion call, I will be directly taking out from my memory and giving here and returning here as 4. That's it. So this is going to be the memoization concept. So for this memoization concept, we can do in two methods. One is using the hash map and another one is using the array. I don't want to show you the solution for hash map because hash map is going to be very simple. So first I will be showing you the array. By using this array approach, your job is to go and find out the solution for the hash map. Just try it. It will be so simple, and it has a disadvantage like it is slightly consuming more time capacity than array, and also we cannot further optimize it. Okay, that's going to be the disadvantage of hash map. But in array, we are going to further still optimize it. Okay, so for memoization, we want to first design the array. For designing the array, we want to design the dimension. So for designing the dimension, we want to check out how many varying parameter we are using. So see here, one is I and another one is j. So these two are the varying parameter I am using. This piles is only the static parameter, it's not changing, right? So these two are the varying parameters. So here, how many varying parameters are there? 2 varying parameters are there. So I want to construct a 2D array. So construct a 2D array. Now in this 2D array, I want to next step, I want to check what is the size of it, right? So for checking the size of it, just check where I starts and where j starts and where they are ending. Where I starts, where j starts, and where they are ending. So I will be starting from where? Will be starting from 0. And it may go up to n minus 1. So my row will be starting from 0 and it may go up to n minus 1. Similarly for j, it will be starting from n minus 1 and go up to maybe up to 0. Maybe up to 0, right? So here also 0, 1, 2 going up to n minus 1. Can you understand this? So it is not exactly going up to 0, it will be going up to 1, and here also it will be going up to n minus 2. So if you put n minus 1, it is not a big deal, but if you put n minus 2, that's also not a big deal. That's also correct. Okay. So here let me do like n minus 1 itself. So that's it is like n cross n matrix. But if you want, you can also do like n minus 1 cross n matrix. That's your wish. Okay. Now the next step is, what is the value I am going to initialize here? So that's going to be the crucial part. Now just check what is the value that is not returned in any of the return value. So see here, 2 is returned here, 4 is returned here, minus 1 is returned here. So minus 2 will also maybe returned here. So what value is not returned? I may tell infinity, I may tell minus infinity, I may tell null. You can take any of these 3 values and fill everything with that same value. Let me take as null, okay? So fill null in every values, in every table, every columns and every rows. So this is how you want to design the array. What is the next step? Next step is I want to add one more base condition here. One more base condition here. If take for example this is a catchy, or let us take as memoization technique, right? So this array name is memo, okay? If memo of I and j is not equal to null, then what should I do? I want to return memo of I and j. That's it, okay? And then at last, instead of returning like this, I want to store and return like just return. As here, this is a Java code. That's the reason I am changing like this. See here, memo of I and j is equal to max of left and right. That's it. So in Java you can use this, but in Python and all, you want to just assign the value, then only you want to return the value. Okay. So using you can use anything in any programming languages. Okay, but it should be correct. That's it. So what I am doing here is, here I am updating it. Here I am updating each and every result. Here I am checking whether it is already computed or not. If it is already computed, then return there itself. Don't want to go for body of the function, so that our time will be hugely reduced and my time complexity will be O of n square and space complexity will be O of n square. And the space complexity is because of two things. One is because of the recursion stack. Another one is because of the matrix we have taken. Okay. So this is your entire memoization code. Fine. Now let me show you the code so that you can go and optimize the next thing. So see here, everything is same. Here I am going to initialize n cross n matrix, and then everything are filled with null, the default value. So here I am using a base condition. If it is not equal to null, then return that, and at last I am updating it. Simple, right? So always the memoization part is very simple, but the tabulation part is bit difficult than this. Okay, and space optimization is bit difficult than the tabulation. It will be going like that, but still watch this video so that you can understand this. Okay, and I also have a DP series, that also you can go and learn it. Okay, now the third thing is tabulation. So why we need tabulation? See here, space is because of two things. One is stack and matrix. First let us remove the recursion stack. To remove the recursion stack, we want to remove the recursion. If I don't want to do in a recursion approach, then I want to do in a looping approach. Okay, how I am going to do in a looping approach? Here also you want to follow some more steps. So see here, in previously what is going to be our table? Let me take this. So this is our table, right? So just a minute. Yes, now this is going to be a table, right? Now in this table, just observe, we used n cross n table and everything is initialized as null. Now listen this carefully. Always check out the base condition. So what is the base condition? If I and j are same, I want to return the piles of I. So let me take example 5, 3, 4 and 5. For this, how my table something looks like. So my table have 4 rows and 4 columns, 0, 1, 2, 3, 0, 1, 2, 3, right? This is how my table something looks like. Yes. Now in this everything are filled with null in terms of memoization. But when you are going into a tabulation, see the return value. What is the return value? It is piles of I, which means in my 0, 0, I want to initialize as 5. In my 1 comma 1 I want to initialize as 3. In my 2 comma 2 I want to initialize as 4. In my 3 comma 3 I want to initialize as 5. Remaining values you can leave as it is, or you can do anything, like you can initialize 0, that's your wish, because here we are just updating the value, we are not going to operate it. Okay, later on you can understand why I am telling that. So remaining things you can leave as it is, okay. So this is the modification I want to do, because I saw the base condition, and base condition they have given like if I and j are same, just return the piles of I. That's the reason I am doing this. Clear? Okay. Now what is the second step? Always forgot this line and strike out it. Now every remaining thing are same, right? Every remaining thing are same, like it is a body of the recursion. Whenever you have reached the body of the recursion, start with the looping for I. I will be starting from where to where. So just clear with this. Before getting into the ith part, first of all let me tell you the relationship between I and j here. So I will be always lesser than the j, and j will be always greater than the I. Can you understand this? So from this I can tell you, if I start from j, the loop is starting from j, then I can restrict the I going beyond the j. So let me take for j first. So j will be starting from where? J is starting from n minus 1 and going up to where? Going up to 0. So always take in a reverse fashion. So for j also it is not going up to 0, because we already saw, right? So I is 0 and j is 0, then return value will be executed. So j will be going up to 1. So it will be 1 up to n minus 1. See here in recursion, j is starting from n minus 1 to 1. In tabulation, just do a reverse fashion, 1 to n minus 1. Okay, fine. Now similarly for I should be from where to where? So I should be starting from 0. See here, starting from 0 and going up to j. Okay, which means here it will be starting from j minus 1 and going up to 0. Can you understand this? Because if I and j are same, it is the return value. That's the reason I am starting from j minus 1 going up to 0. Okay, always do a reverse fashion to the recursion in a tabulation. Okay, now what is the body? Just write this body as it is. So see here, left is equal to piles of I minus, so here it is what? It is a recursion call. This dp is a recursion call. Instead of recursion call, let us take this array as memo. Write memo, and what are the varying parameter of it? It is I plus 1, and another varying parameter is j, right here, and the right is equal to piles of j minus memo, same thing, memo of I and j minus 1. That's it. And at last what should I do? I'll be take memo of I and j is equal to maximum among L comma R. That's it. Okay, and then at last what should I return? After finishing this entire for loop, what should I return? That's going to be the next thing, right? So here what I am returning? Here I am returning dp of 0 comma n minus 1. Similarly here I want to return memo of 0 comma n minus 1. That's it. So this is going to be your tabulation code, and tell me what is going to be the time complexity. Time complexity will be O of n square, and space complexity is also O of n square, but it is only because of the matrix we have used, not because of the recursion stack. So we are optimizing it still further. Okay, so see here, let me show you the code, just a minute. So see here, we want to modify the array. So wherever the two indices are same, I want to initialize them as pile of I. That's the reason why I did here like that. Okay, now j will be starting from 1 up to n. Instead of 0, you can also put 0 here, or you can also put 1 here. If it is 0, then this for loop is not executed, however it is skipped. That's the reason why I put 1 here. That's your wish. If you put 0 here, it will be running fine, or if you put 1 here, it also running fine. Can you understand this? It's simple thing. Okay, now this is also a similar thing what I wrote there, and then here dp of I and j is equal to maximum among both the things. So like this also you can do, or like that also you can do. Okay, at last I forgot to write greater than 0, right? Written this greater than 0, I forgot to write this. Okay, fine. So this is going to be your tabulation method. Now in your tabulation we have used a plenty of space. Let us go and check whether I can optimize my space. So the next method is going to be space optimization. Next method is going to be space optimization. Okay, so how I am going to do a space optimization? So here I am using n cross n matrix, right? So now I want to arise a question whether I want n cross n matrix or I don't want n cross n matrix. So see here, always whenever we are doing this, go to the inner loop, here. Okay, inside the inner loop I used only j and j minus 1. What it signifies? It signifies I am using only current column and its previous column. I didn't use n columns. I only used current column and previous column. So let me take two arrays of n column. So let me take two arrays. Just take current and previous. So these are going to be 0, 1. These are arrays, okay, up to n minus 1. And similarly here also it will be starting from 0, 1, 2 going up to n minus 1. Okay. So what this current represent is dp of some value and j. What this previous represent is dp of some value and j minus 1. Can you understand this? Now with this reference, what should I do? The first step is we want to modify here. How I am going to modify here? Current of I. Okay. Just a minute. Let us strike out this line. We can do inside this. Okay. Now instead of this line, I have done these two things. Initialize two arrays. One is current, another one is previous, of size n. Okay. Now in between this. Okay. I want to initialize one line. Current of I is equal to files of I. That's it. Sorry, current of j is equal to files of I. Why I am doing this? Because see here, we are just updating each and every values inside my current, so that in future I am going to take that value. Okay, just listen to this, you can understand this. So in these two lines we want to change this. In first line it will be files of I minus, here comes dp of I plus 1 and j. So j means it means what? It is current. So current of I plus 1. Similarly here it will be files of j minus, here comes dp of something j minus 1, which means previous of I. That's it, previous of I. Okay. Similarly, at last, after finishing this inner loop, I want to do something. What is it? I want to copy everything in the current into the previous. In the current into the previous. Okay. And at last, what should I do here? You can either take current of 0 or previous of 0. That's your wish. Or previous of 0. That's your wish. That's it. So by doing this, you are converted the tabulation code into a space optimization code. Now tell me, what is the time complexity? It will be O of n square, and space complexity will be O of n. That's it. Okay. So it is basically like I am taking two columns, computing the current thing from the previous thing, then again take the two columns, computing the current thing using the previous thing, again take the next column, here also next column, like that. Can you understand this? Instead of taking the n columns, I am taking only two columns, which is required. Okay. So let me show you the code. Just a minute. Yes. So see here, the same thing I written there. Okay. And then here, current of j is equal to files of j. Oh, there I written I, right? I. Sorry. Here I changed this j, but here I forgot to change it into j. Sorry. Okay. Now, rest of them will be same as I written there. Okay. Now at last, previous is equal to current dot clone, and at last here you can either put current of 0 or previous of 0, that's your wish. And I made a mistake here also. We want to check greater than 0. I forgot. Okay, fine. So this is what the space optimization looks like. Fine. So it is basically like we are taking two columns. Like first this will be my previous and this will be my current. Okay. In next this will be my previous and this will be my current. Computing the current again. Now this will be my previous and this will be my current. Again this will be my current and this will be my previous. At this point you will be having the answer at this particular column. That's the core logic behind this. Now hope you understand this, right? Okay. So if you still cannot understand, go and dry run it so that you can understand this clearly. And so till now we have seen about the DP approaches, right? So we have started with the brute force, then we are just optimized, and we came to a conclusion like a time complexity of O of n square and space complexity of O of n, right? So now listen this carefully. We are going to use another approach also. This is going to be the tricky approach. So this is what I told you, a twist. Okay, one line answer. Okay, so let's just start it. So see here, first of all, for this absolutely Alice will be winning, so it will be returning true. For this, who will be winning? So see here, you are Alice. First you want to take which one? Will you take this 3 or will you take this 2? I'll be taking this 2 only, right? If I am Alice, I'll be taking this 2. Why? Because in next attempt, Bob will be taking any one of these 2 or 3 such that I'll be taking the 15. For example, Bob took this 3. I'll be taking this 15. So again I'll be winning. So here also it will be true. Can you understand this? Again. So here also, if I am Alice, I'll be taking this. Bob, he has no choice. He will be taking this 15 obviously. Again, I'll be taking this. So now he has no choice. He will be taking this. So here also Alice will be going to be winning. So here also it will be true. Similarly here Alice will be taking this. Bob will be taking this. Again Alice will be taking this. Again Bob will be taking this. Bob will be taking this. Again Alice will be taking this. Can you understand this? Here also Alice is going to be winning. So from here I can tell you whatsoever the numbers, absolutely Alice is going to be winning. So that's the reason why I have told you it is a one line answer. Just we want to return true. For all scenarios, Alice is going to be winning. Can you understand this? Why it? Because many will be having a doubt, right? Why it is? Because all the values are positive. That's the reason. Now hope you understand, right? If it is negative, for example, just a minute, 5 minus 10, okay, just a minute, minus 10, 5 minus 10. If this is a scenario, first of all, Alice, he doesn't have any choice. He have to take this minus 10 or this minus 10. Let us assume Alice is taking this minus 10. Okay. Now Bob will be taking this 5. Okay. So let me, instead of this 5, let me change this as 6. Okay, 6. Now Bob will be taking this 6. Okay. Now again Alice will be taking this 5. Again Bob will be taking this 10. So now what is the value of Alice? Value of Alice is minus 5 and value of Bob is minus 4. So minus 4 is greater than minus 5. So here you will be returning false. Can you understand this? So only because of the positive values, always Alice wins. If it is negative, there is a chance of winning for Alice and Bob. There you have both the cases true and false. Can you understand this? So by using this approach, you can achieve a time complexity of O of 1 and space complexity of O of 1. So this is going to be very optimized approach. Now hope you understand this approach, right? So this is what I told you, the twist, and that's it. So that's it. If you understand this question and like this video, please like this video and subscribe to my channel, and don't skip any videos in this DP series because all the videos will be helpful and you can definitely go and crack the interview questions and also the Leetcode contest. Okay, and if you have any doubts or if you found any mistakes, just comment below. I'll be commenting the answers for it. Thank you.